More for me.
Okay, so we have degree 3, negative a, degree 3, negative a. Okay, so I want 3 directions and decreasing, so something like that. If x goes to negative infinity, f of x, oh, I should put y, it's easier. Y goes to, if x goes to positive infinity, y goes to, hi, thank you. Okay, so left arrow is up, right arrow is down, left arrow up, right arrow down. Any questions? Did I do it correctly? I'm just completely second guessing myself on everything now. Thank you. Goodness, you guys are here for me. I missed you yesterday. All of table 4. Whole table 4 missed you all. Every single one of you. I was sad. Oh, don't be sorry. It's okay. Just wanted you to know I missed you. Okay. Number 16, last one on this page. Find all zeros. Oh, snap. I have a trinomial. That means that I have to do quad formula. So 0 equals x squared minus 12x plus 8. Okay, this guy's easy. That's x equals 0. One single real root. And if you got stuck on number 3 on the quiz 2 review, this is what you were supposed to do there. A equals 1, B equals negative 12, C equals 8. Did anybody try the diamond in box? I stared at it. I felt like it should work, but it doesn't. Mhm.
Are you gonna have one of these on the test, right?
Nope. I'm not going to make you do quad formula on the quiz tomorrow. There's no quad formula on the quiz tomorrow. Well, you'll have a note card, so I mean, I feel like that would be much more fair to ask.
If you put it on the test, could you just make a lot of room? Because a lot of the time it's like kind of like.
I'm just thinking about, I just made the keys. I think there was plenty of room for everything.
Like, 'cause it is like kind of hard.
Thank you for that feedback. But again, please do not fear. There is no quad formula on the quiz tomorrow. No quad formula on the quiz. Okay, what was the point of having the quad formula on the quiz review? It's because I wanted you to see how to graph those fake out bumps, if that makes sense. Anyway, x equals 12 plus or minus. Okay, so this is going to be 144 minus 32. Oh, you guys see what I did? Factor tree. hold on. Lila, that paper right there, that's what we're doing tomorrow. I just wanted to send it home. Okay, real or complex here? Real. And now you might be like, oh, well, I know how to do number 3 on the quiz review now, and I know how to do number 6 on the quiz review now, because we just did that warm up. Mrs. Talbot, you should have flip-flopped those and had that warm up yesterday. Except, just want to remind you, we did that in number 74 and 75 in class previously. But anyway, okay, so that's it for that. Now, if you could find the quiz to review, please. Okay. I will take as many questions as you have. However, I would appreciate you telling me when you're unstuck and that you can keep going so I can move on to the next question because I don't want to do all the problems out, but I will try to get you unstuck from wherever you are. What questions do you have? And also, unless you think that the key is wrong, that's a different situation because Mrs. Talbot's special. Super duper special. Which what, honey? Oh, yeah. Okay. Now I want to be really careful here and note this. Okay. So I'll start both of them for you and then hopefully you can tell me where you get unstuck. So y equals a. Okay, the 0 is going to be x. The 4 is going to be x minus 4. This one's going to be x, switch sign, and then x, switch sign, switch sign. Okay, now it's really important for you guys to know that proper factored form doesn't have i's or weird roots in it. So this might look like factored form to you, but the answer looks different, and that's because you need to multiply this part out to get rid of the i's to have the proper looking factored form. Okay, so do you know how to multiply this out right here? Okay, so you're going to do a 3 by 3 box for this. Does that make sense? And then you're going to write down the point 2, 392, plug that in for x and y and solve for a. Okay, now do you want me to, does this one have a mistake? Is that why you're smiling? On the key?
That's what I thought. Yeah.
Well, I think that that would be good news because that would be easier than 1/4. Okay, so let's flip the page over to the answer key. And say that this is probably -1 because the extremely brilliant people say so. And Mrs. Talbot was left to type this whole thing herself. So let's just say that if you get -1 for A, that it's probably me and not you. It's like a breakup. It's not you, it's me. That's supposed to be funny. Okay. Anyway, moving on. Okay, now you want me to help you set up number 10, Gio? Okay, so y equals a. Is this one wrong too? Is this one wrong too? In the key? Are you, okay, okay, well, we'll see. Okay,
I
so
think it might-
it's probably wrong.
no, okay.
I think I'm wrong. Okay, anyway, write the equation in standard form of the fourth degree polynomial that has a double root at x minus 2, so x plus 2 squared, and a single root at 3 plus 2i, so x, switch sign, but then there also has to be the conjugate, x, switch sign, switch sign. Okay, so let me slow down on that piece. If this exists, this also has to exist. I tried to give you a hint by saying fourth degree polynomial, which then you should know that there should be four thingies. Yeah, okay, so you're gonna multiply these in a 3 by 3 and then plug in, solve for A, and then you gotta multiply out all the boxes to get the standard form. But always start with the conjugates because those will come out nice. Okay, now on the mistake that people think that I made, which I definitely did, it's definitely me. Should I keep going so we can, what did you guys get? Did you do this? Okay. It's probably me. Oh, you got the, I'm just gonna keep going. I don't know.
So,
McDonald's. Yeah. How are we doing so far? Do you guys all understand where I got the 4 from here? Super important you understand where I got the 4 from. Yeah, it comes 4 wait, yeah, negative 4i squared. So here, I'm just gonna write it. Negative 4i squared, and then the negative and the I squared cancel and you get 4.
mm,
The I squared and the negative cancel.
what if it's just I? It's just,
Yeah, but we wouldn't have that,
well, let's say,
but it wouldn't cancel.
no, like in a different situation.
Yeah, it would just be like,
I would just negative.
no,
I.
just I. It has to be squared to be the negative. Okay, anyway, and then you do, I don't know what you want to do, a 2 by 2 for this? Is that what you did next? Why am I doing this? I can do this in my head. And then 3 by 3? Jacob? Did I? Okay, okay. Does A come out to be 2? Okay, I'm gonna let you play with that one. Stella. Okay. Anyway, other than those, you guys kind of getting where those are going now? I hope. You guys okay? Um, anything else from this other than those two or any other additional questions about these two? Ask me about what?
I wanted to ask you about the graph of five.
It being wrong? Well, there's infinite, you don't know what the graph is. That's the problem. Okay, so Okay. So this is 5, right? For sure. So you think the wrong graph is on the answer key, is what you're saying?
So I think
Hmm.
put 5 + 333 and 5 - 333. I think it's supposed to be an answer.
This sounds like me. Okay. Okay. So yeah, there's definitely supposed to be an I in there. Well, this number is way bigger than that number. And it's subtraction. So yeah. Hmm. No? Okay. All right, let's head over to the key, people. 1 ± 3, I reach 7. Where did I even get this? Okay. Mhm. So I'm thinking what happened was, whatever the answer for this is, I probably typed that into the thing that shows the graph, right? I'm thinking probably. Okay. But this is something I want to talk about, and I actually went to talk to Coach T this morning about we are working on a conjecture yesterday to determine where does the fake out occur? Is it below, above or below? Is it on the left or the right? Can you tell from your roots? And he said no, not till calculus. What you're going to do is, and I'm just going to tell my mathy people in here, Google how to find the derivative of a polynomial. Once you find the derivative of a polynomial, then you can plug in and it will tell you where the slopes are of each of the spots. Once you get a slope of 0, you can tell that's where the bump is. That's your calculus hint for that. Do we need it for math 3? Absolutely not. Okay, so what I'm trying to say is actually in pre-calc, you'll work on extrema. And extrema are max and min. And this would be, so if you're in Mr. Guinan's class next year, I don't know if he's going to be here, but whatever, let's just pretend. And you have one of those bumps, it would be a local max or a local min because it's not the overall max or min. These are not terms that we use in math 3, but you'll learn those next year. Anyway, okay, now this is to answer the question from yesterday. Okay, so I know this has a positive A value. I know this thing is going to start low and high. I know there's going to be a fake out bump that's not going to cross the x-axis. Where does it live? Does it live over here or does it live over here? And you don't know. The answer is you don't know. There's infinite number of correct, probably not infinite, but there's a lot of correct answers for this. Just because there's a lot of room over here, I'd probably make my fake out bump here and then go through there. Yes, honey.
So I usually start off low, but in high, even though I yeah, the X squared right there.
I love your question. Okay. How many X's are here? How many, okay, now, how many X's are here? This is a degree 3. You cannot look at this. If there's more than one thing in the parentheses, you only look at the front. Okay, and why is that? Pretend that I asked you to put this into standard form. Okay, first of all, what size box would I need for this if I put this into standard form? 3 by 2. Okay, and without drawing the box and without doing the rest of the box, what would be in the first box? X cubed, exactly. So if it's in standard form, the highest exponent would be cubed. So remembering degree is highest exponent, highest exponent. So what I'm saying is if there's more stuff in there, just look at the front. And I'm really glad you brought that up because a bunch of people asked me yesterday after you left and I was like, oh, I should have said that yesterday. Okay. So when you're doing your quiz, it's gonna feel weird because it's gonna give you some information. It's gonna say, sketch me a graph with, it's not gonna give you an equation. It's gonna say, sketch me a graph with 1 single real root and 2 single complex roots. You might have your bump above the x-axis, you might have your bump below the x-axis, doesn't matter. Your graph satisfies the information given. So there's multiple correct answers. And I don't know, to be honest with you, how to tell from this whether or not my bump would be here or if it would be up here. I don't know. I honestly don't. Could I sit and do the derivative? Sure, I could. Do I want to? Absolutely not. Can you guys look it up when you're bored? Yes, you can. Okay. Anything else from the quiz review? And just in case any of you come across last minute questions, I get here at 8 tomorrow. So you want to come in early and ask me anything, I will be here just in case, or correct my incorrect work. That'd be great. I'm sure that there are at least 3 or 4 messages from Ms. Rice in my Google chat about Excel. Figure out what I did. I must not have liked that problem. I don't know.
If you don't have what you're doing.
Volunteering?
You're good at your skills.
Yeah, people skills are what people want, which is what you have.
Okay.
Yeah.
Good manners. Social skills.
What about polite?
I don't have really formal. I
No,
didn't
it's-
have that.
Just an idea.
I said thank you to 3 people on the way after
Oh.
I did.
Where did you apply? This is none of my beeswax, but
This,
I love that story.
and I loved it.
I want to.
If I get it, I get a 25% on discount. Anything I did. So
I just want to drive across the bridge for my job. I don't know. That's just me.
I just like driving.
Yeah, but it's the bridge toll like every time.
So think about it, you use like most competitive to say about
Yeah.
$8. No, but think about it. It's worth it. Yeah, it's a big- Okay, well, think about it. I can make that project back. Like, let's say every time I work, I buy something for someone. It's like $50, but they get 25% off already, right? But you like pocket 5%. And like, I don't think someone's gonna buy something for $20 and you get 25% off this. I think we should start with right now.
Anywho, moving on.
I think it's easy. You did? that might be really dark, but- That's so funny. Yeah. Oh, we have notes? Notes. Okay.
Okay, we did most of this yesterday. There's two things I want to teach you today that are in addition to what we did yesterday. The first one is what to do when you have a term missing. Remember that homework problem you did a couple weeks ago? It was like list the coefficients in order. And remember that A0 equals blah, A1 equals blah. Okay, the reason that you did that was because they were trying to get you to notice if a term is missing. I want you to look at the dividend, which is the first big polynomial in parentheses, and tell me if you can tell that a term is missing. Yes, I can.
X squared.
Yes, perfect. The x squared is missing. Okay, so what we need to do is figure out how to deal with this in our division problem. And then the other thing I want to teach you is how to do long division so that those of you who would rather do long division can do long division. Those are my two goals for today, other than having fun with the remainder and factor theorems, which are the things I put on your tables. Okay, so what size box? 4 by 2, yeah. And remember, as I said, that works most of the time, not all the time. Okay, and then what I tell students to do, you know how I line up the things underneath? So x to the 4th minus 6x cubed, and then throw in a 0x squared for the missing term. And that will help you. Okay, so first box, x to the 4th. Top has to be x cubed. Bottom has to be negative 2x cubed. Okay, I have negative 2x cubed tiles. I need negative 6x cubed tiles. So how many more do I need? 4 more. Negative 4x cubed tiles. So the top has to be negative 4x squared. Positive 8x squared. Okay, I have 8x squared tiles. I need 0. So I'm going to take away 8. I have 16x tiles. I need 18, so I need 2 more. Satisfying. Okay. Okay, this is the one and only time I'm going to do long division. I will do it with the box for the rest of the year. But if you love the long division, by all means, go for it. I have some conjectures on who is going to love the long division. We will see. Okay. So we have divide, multiply, subtract, bring down. And when I divide, I like to ignore everything except for the thing in the front and the thing in the front for that moment. So how many times does x go into x to the fourth? X cubed times. Okay, so let's divide. Then multiply. And on this one, you have to make sure to distribute. So you have x to the fourth minus 2x cubed. So in this case, divide, multiply, make sure to distribute. Subtract with parentheses. The first two things should cancel. That should happen every time. If they didn't cancel, you did something wrong. You got to back up the train. -6 minus -2 is -4, right? Yeah. -6 minus -2 is -4. Okay. And then bring down. Well, it's kind of helpful to see that you're getting the same stuff out of the box. Like it makes you feel like I'm not going, rogue over here. Okay, bring down. Okay, now I just look at these two. So divide. So x goes into that -4x squared times. See that you're getting the same answer over here. Is anyone already hating it? Nope. This is completely optional.
Please, I don't, right?
I would just write it this one time, just for me. Okay.
This is a different time, so it's like different step, you know?
Yeah, I mean, I think for us, we've been trained with the box so heavily that why not use it? As I said, this is the one and only time I'm going to do long division, unless one of you guys brings me a question with long division. It's not like I'm not going to answer it. There are people who are going to love it though.
In your hand.
No?
Sorry, Miss Falcon, maybe next time. And a Dax 11.
Oh, yeah, Dax will love it. Yeah, Dax is going to hate it. And he'll tell me. He sits right here. Yeah, he'll voice his opinion about it to me. It's going to be great. Okay. Anyway, that's the one time I'll put you through that. You don't have to do it. The box is available for you at all times. Okay, now I'm not going to do that again. For example, 2, we're just going to do the box. Actually, I was thinking maybe you guys should do the box. And to get to the end, this one does not come out evenly. There's a remainder, so we need to remind ourselves what to do with that. Okay, so number example 2, what size box do I need? 3 by 2. Okay, so draw your 3 by 2. Three, 2 things.
Oh, and you do the thing at the bottom, right? Right? Or maybe not.
Okay, now we had a few people absent yesterday. I'm gonna still do this up here, but silently. You guys try to do it on your own. Glance up at the screen if you get stuck. -21?
Maybe it's supposed to be three.
Yeah.
Instead of nine.
Oh, thank goodness.
I looked at it.
Thank goodness you're here. These numbers are much better. Gonna say, there's a lot to multiply. But still, -15? -15.
Yeah.
Hmm? This is how you find the remainder. You take this minus this to get the remainder because it didn't come out evenly. So whatever this is minus whatever this is.
Are we gonna-
I need you to know how to do -1 minus -5.
But I kind of think that would be -6, right?
No. Mm-mm.
I thought that was only multiplication. I don't know. I'm trying to stop it.
Don't be sorry. I love you.
Stop it.
Yeah, seriously.
Keep running.
Okay, so I took the 4. Are we clear on where the 4 came from? Is the 4 correct? Okay, and then
How do you
you
know?
put it over the divisor. I'm just like second guessing myself completely now. It's good?
Yeah.
Okay. Phew. Okay, and then I take that number and I put it over the divisor over here. Okay. Whew. All right. Now, set this up. Okay, and then you don't have to don't write the numbers over here in red. This is just for me. This polynomial is also on that paper that I gave your tables. So after you get this situated, locate that paper. These little red numbers over here are your table group numbers. And you don't need to write those. I gave each table group a different assignment in this paper. What? You guys are 7 and 8.
Oh, we get two?
Yeah, because. There's a table 8 in this group. So,
You got it?
okay, so once you get this situated. Slide your notebook aside, you're not gonna use that for a few minutes, and you're going to take that paper, put it in the middle of your
Yeah,
group.
you guys got that.
Okay, and you can use a calculator. The first thing I want you to do is plug in the number that I've given you. So table 1, I told you to find f of -4, so you're gonna plug -4 in for x, like a function machine, and get an answer. Does that make sense? Okay, and then underneath that, you're gonna write nicely on this paper, by the way, and give it to me in a few minutes. Somebody, elect someone with nice handwriting. And then below that, you're going to divide by the associated factor. So I switched the sign, I took that number, switched the sign, made it into a factor, and I want you to divide with polynomial division with the box. I'll walk around and help. Calculators are fine. So now you.
It's like 41, right? I thought, yeah, you probably. Equals 41.
You guys, A and B are separate problems. Do not use your answer for A in B. Oh. It's saying divide the original polynomial by the factor. I should revise those directions.
You guys need to go.
Yeah, you do the box. The box thing we just did in the note.
No, you guys need to go get that. Don't forget to put people way out if they're calling you, because I tried to in and out, like, full way doesn't know. Hey, huh? You know you have many options. But we don't. Yeah, nothing like that. Other, you know.
Unless.
One Martinez, one Vallejo. One Martinez, Vallejo, near Daily South. Walnut Creek. You like that? Should apply for one. No, I only apply to places for the benefits, come on. I applied to those two. That's not that bad. Like, think about it, it's only 15 years. I guess I'm more probably. Could do that as well. Find out about it. If you go like something in the beginning, you just get it. But at least by the middle, you know what I'm saying?
Oh,
That's
God.
so many other words.
Is it so?
They have to accelerate up to 7. Stop, they have with the UE, like, accelerate, they can also just make it like tricky, like. But I don't think you can slow his thought on this guy. But, with all the trees in the way, the bushes on Second Street. What? Huh? It's kind of- No, on Second Street, like, you know, like 7-Eleven, so like the left, like road.
Plus 5 over x minus 1.
I haven't got pulled over yet. Well, I've not got to take, I've gotten pulled over, but not got to take it. So it's like,
Okay,
cancel each other.
I see that you guys are not. Hello?
Ah,
Okay.
Sorry.
Okay, now we're going to identify 2 theorems. Because you're smart people, what do you think the remainder theorem is?
The remainder of what you have.
True, okay, but based off of your answers from A and B. What do you notice about your answers from A and B, specifically
There's a
talking
remainder.
about the remainder? See if anyone can put it in intelligent words. You're like, I'm out.
Yeah.
What did you notice about your answers from A and B, specifically having to do with the remainder? Yes, honey.
When a polynomial.
No.
Divided by.
Not ChatGPT.
Oh, no, it's Google.
No, this help. I want original thought, thank you.
How about it's the same answer?
Yeah, but did you come up with that on your own?
That's too smart for me to understand.
That, what answer did you get, honey?
It says when a polynomial.
No, what answer did you get for A, honey?
41,
What answer did you get for the remainder in B?
84. Wait,
No.
no. 41 x minus 3
So what you're saying is
divided,
41 for both?
maybe not.
Yes.
Yes.
So you could have come up with that on your own, that they were both 41? Okay. What answer did you guys get for
Yeah, I don't think.
A? Negative 15. And what did you guys get for your remainder? Negative 15. Oh, interesting. Okay. And table 2, what did you get for A? 5. And what did you get for your remainder? Huh. Table 3, what did you get for your answer for A? 11. And what did you get for your remainder? 11. Table 4, I'm going to come back to you because it's not your fault. You were all absent. Oh, but it's 9. It's 9. It's 9. It's 9. Okay. I got you guys. Okay. Now let's plug in 0 real quick. That'd be 5, right? Okay. Table 5, middle table. What'd you get for your answer for A? 5? Okay. And then what'd you get for your remainder? Table 6? 15? Did you get your remainder of 15? Table 7? 41 and 41? Table 8? And 89? Okay, so what do you think the remainder theorem is? In teenage words, not Google words. Okay, but what stays the same? Let's as okay, hold on. I like it. The remainder is the same as, okay, I don't want to say divide by factor because that has to do with the remainder. I want to talk about the other thing we did when it's plugged in. Geo for the win. Okay, now. I want to look at 5. So I want you to notice something. First of all, do you notice they all came out not evenly, which is kind of unsatisfying? I want you guys to take a look at the 5 on the edge. If you're doing a box and the last box, it has to be 5, what kind of stuff would you have to have as a vector? Okay, let me draw you a visual of what I mean, and this is the last thing I promise. Okay, I'm saying if the original problem has a 5 in it, and you want no remainder, what are the possible factors you could have? There's a 4. 5, -5, 1,
Zero,
-1.
not zero. Negative zero?
Okay.
You already said zero.
Okay. You can easily tell if these are gonna work or not based off of this number because they have to go in evenly. Okay, but for us, we're gonna write a factor has a remainder of 0. And you guys know that, but it's actually not a theorem, it's a corollary. It's a sub rule to the remainder theorem. It's basically the special case. When you get 0, that means that it's actually a factor and an x-intercept. All right. That's it. I appreciate you all very much.